Hi guys, this is Joshua LaForge here at Channel Islands High School in Oxnard, California. I'm going to teach you how to work on a problem related to an object rolling down a hill, how to solve that using torques specifically, and all with the goal of doing really well on the AP Physics C Mechanics exam. So we're talking about an object that's rolling down a hill, and so there's two things that are going on here. We've got just forces and we've also got torques. So let's draw in the forces first. Now, anytime an object is rolling, on the test it'll say an object rolls down a hill without sliding. Without sliding means that the force of friction is enough to keep the object spinning. Anytime an object is rolling, we have to have a force of friction because it's the force of friction that makes the thing turn. The force of friction applies the torque. The force of weight and the normal force, you should know how to set those up already. It's just like an object sliding down a hill, and if you're not good at objects sliding down a hill, well, then that's what you need to practice before you move on to things rolling, because this is more difficult. Now, how are we going to figure out how this thing moves? More specifically, what we want to figure out is how fast is this object accelerating down the hill. Okay, you can solve for other things, of course, but if you know how to solve for the acceleration, you can solve for easier things, because usually there's steps along the way. Now, first of all, we need to ask ourselves, what determines the linear acceleration of this? And that's, of course, the net force. So we want to write an equation for the net force as step one. That's always step one in a force problem. In this case, because we're on a hill, the net force is equal to the force of weight, but only a component of the force of weight. Only the force of weight that is parallel to the surface. So the net force is equal to force of weight parallel to the surface. It's also related to the amount of force of friction. So force of weight parallel minus force of friction gives you the net force. The problem is that when we're rolling, we're experiencing static friction. And static friction isn't a hard and fast number like kinetic friction is when we have things sliding down a hill. When it's sliding, you can just plug into an equation and get the force of friction. But when you're rolling, it's not that simple. And so we have to figure out the force of friction some other way. So we're going to use this equation later, but I need to come back to it. First, I need to think about what's causing the spinning, and that's torques. Alright, now we need to talk about the spinning that's involved in an object rolling down a hill. So we're going to worry about torque now. We got two torque equations that we want to focus on. So we should know by now that torque is equal to force times radius, and also torque is equal to moment of inertia times angular acceleration. We need both of those things right now if we're going to help to figure out what the acceleration of this object is. So let's start with how much torque is on the object. We can figure out how much torque is on the object by using this equation. But like I said, we don't usually know the force of friction, but we can figure out the relationship here. So I can plug this in because I know that the force of friction applies the torque here. I can turn this into torque is equal to the force of friction times the radius of the object. On this side shows my relationship between torque and acceleration. Right now, it's angular acceleration, but remember, acceleration equals the radius times angular acceleration times alpha. And so if I change that around, then I know that alpha is equal to acceleration divided by the radius. Okay, so I've got two things going on here. I've got this equation that talks about the acceleration of the disk spinning, and I've got this equation that talks about how much force is on the disk. If I put them together, then that unites my unknown with the thing that I want to find. Okay, so this allows me to figure out how much force of friction there will be on the disk. Notice, I said that you couldn't just plug in an equation to figure out the force of friction. Well, you can't, and here's why. Because the force of friction on something rolling down a hill depends upon the moment of inertia, or the rotational inertia of the mass. It also depends on how much it's going to accelerate in the first place. So unless we know how much it's accelerating, we can't just figure out the force of friction. Our next step is going to be to take this equation and the equation we came up with before and unite them to get our answer for our acceleration. Alright, now it's time to finish up. So we've got two equations. One is related to the rolling. So we used the rolling that was happening, that circular motion, to figure out that force of friction is related to these things. We also used the linear motion to figure out that the net force is related to those things. And both of these things can help us to solve for our acceleration. I need to play with this one a little bit more. And what I need to remember is that the net force is always equal to mass times acceleration, the mass of the object, right? So let's plug that in first. So this is going to allow me to create a nice easy equation for the acceleration. And actually, it's the same equation for acceleration that you would have with any object moving down a slope, even if it's sliding. So the acceleration of an object down a slope is equal to the force of weight parallel to the slope, minus the force of friction divided by the mass. But when you're rolling, it gets complicated to figure out, well, how much force of friction is there? Fortunately, we have an equation for that over here. So I'm going to plug this in, and then I'll have a good equation for my acceleration. Now, I can obviously substitute in for this. I can also simplify this and make it better, but this is a pretty universal equation for the acceleration of something rolling down a hill. And the rest of that, I'm hoping that you can do. You'll get some practice in the practice problems, but I hope that this showed you the general idea. We start with the linear motion and create an equation there. We start with the rotational motion and create an equation there. And then we bring them both together to figure out the acceleration. So, give the practice problems a try, and I hope I'll see you next time.